What's up, young mathematicians? Thank you for stopping by here at Tau 2 Pi. I am Caesar the Tutor, and today we are going to be talking about inverse functions. What is the inverse of a function? The inverse of a function is the function itself which undoes what the previous function did. If you think about subtraction as a function and addition as a function, then we can say that those two undo each other. If you add something and then you subtract it, you simply undid what you did before. Inverse functions are nice because there is a special relationship between those functions. The input of one function is the output of the other and vice versa. Knowing this, sometimes it is able to come up with an equivalent expression for a difficult function to be able to find inputs and answers quickly. One such example is a log function, where it's not so easy to tell what the log base 2 of 8 is, but it is a lot easier to tell that 2 to the x equals 8 will have to mean that x equals 3. And the reason we were able to do that is because the logarithm function and the exponentials are inverses of each other. So instead of trying to solve this problem, we convert it to an equivalent expression and try solve this one instead. In today's lesson, we are going to see how inverses and their parent functions are related, and we're going to see a few graphs as well. You're also going to see what it means for a function to not have an inverse. And without any further delay, let's get started with the lesson. Let's start with the definition of the inverse of a function. Let f of x and g of x be two functions. If, and here we have our famous if f of g of x equals x and g of f of x equals x, then we call g of x the inverse of f of x, and we denote it f inverse of x. So now let's see if we can break it down. F of x and g of x can be any two functions. And if we compose one function with the other and end up getting x, and we do the same thing in reverse and also end up getting x, then we can say that g of x is the inverse of f of x. Or we could also say that f of x is the inverse of g of x. These will be inverses of each other. And to denote the fact that they're inverses, to let the reader know that, look, this function is the inverse of this function, we would sometimes replace the notation with an f that has a little -1 right attached to the f, and then an x. So this would be the inverse of f of x. Not to be confused with if they put an f of x and then a parenthesis around it and then a -1. This means something else than that. These two things are not the same thing. In the simplest of examples, let's take a look at f of x equals x plus 2, g of x equals x minus 2, and we're going to check whether these two functions are inverses of each other. So the first thing we're going to do is say f of g of x. And we know that that simply means take g of x, whatever g of x is, and plug it in for x into f of x. So this is just going to be whatever that is, so x plus 2. And then we're going to take this, plug it in here, and we have x minus 2, and we end up getting that x minus 2 plus 2 simply equals x. But now we have to check the other way around. So we're going to say g of f of x equals. And so you're going to take g, so g equals something minus 2. And then you're simply going to take f of x and plug it into here. So x plus 2. And you're going to get x. And so this shows that g of x is f inverse of x. Now let's take a look at the graphs of f of x and g of x and see if we can figure out what's going on. F of x is a line with a slope of 1 and a y-intercept of 2. So I'm simply going to go like that, and I know this line goes like that. On the other hand, g of x, while it does have the same slope, it has a y-intercept of -2. So instead of being up here, it's going to be 1, 2, somewhere down there, and we're going to say this one's going to go like that. Now, the slope didn't change at all, but the y-intercept did on the inverse. Up here we have a 2, and down there we have a -2. Let's take a look at a few other graphs and try to see if we can figure out or spot what the inverse is doing to my function. In this graph, we have y equals x cubed and its inverse, which is y equals the cube root of x. Now this one over here, you might not know what it is, but I'll just tell you that it's the graph of y equals e to the x. And this is its inverse, y equals natural log of x. I'm going to go ahead and merge these two and put them in the same graph so that you can see what's going on. As you can see from the graph, the inverse is simply a reflection across the line y equals x. Whatever you used to have on the right-hand side of that line, you now have flipped on the left-hand side of that line. This is exactly what it means for one function's x values to be the other function's y values, and for the second function's x values to be the first function's y values. In reality, all we're doing is flipping these two coordinates, and they become the coordinates of the new point in the inverse function. And the way we can visualize this is that if we have a function like f of x with some point xy on this plane, then if we apply the transformation of the inverse, it's going to simply take this point and flip it around and spit back a point in reverse order, and we are going to call that the inverse of f. So, when given the graph of a function and you're asked to find its inverse, the simplest thing to do is to take the points you're given and flip their coordinates. So for example, in this case, you are given the first point as 2, 0. So now we know that the inverse of that point is going to go over here as 0, 2. And so we're now going to plot the point here, 0, 2. And if you think about it, the inverse itself is what we call a transformation. It takes something from this side, it applies the inverse, and then it shoots it over here. Let's take a look at the second point. The second point says, well, this is 0.31, but applying my inverse transformation is going to flip those 2 points, and over here is going to appear as a 0.13. So rather, it's going to go 1, 3 up here. And then the last point we're given as reference is the 0.62. And now applying the transformation and bringing it over here to the inverse is just going to flip those two values. And now we're just going to do 2, 6. And now we have a graph that looks like this. And if you take a look at these graphs and we merge them, we can clearly see that the line y equals x clearly separates these two. And if we fold this line, we have exactly what we have on the top half as we have on the bottom half. Now, because applying the inverse switches the position of the x and the y, sometimes it's possible that when you do this, the result itself ends up being something weird. For example, if we take the x squared function and apply the inverse, we know that what it's going to do is going to reflect it across the y equals x line, which is this line right here. And doing that is going to create this graph on this side that looks like this. But We already know that by the vertical line test, this is not a function. When I perform my vertical line test, I hit 2 points, and therefore that is not the graph of a function. So in order for us to be able to call this the inverse of this, we are going to need to eliminate this side so that when we flip it over, we only end up with the top part. And if you notice in this case right here, we're simply saying that f of x equals x squared, but only for values of x for which x is greater than or equal to 0. And because the domain of this function is x is greater than or equal to 0, which we can write as 0 to infinity, then we know that the range of that function, which is f inverse of x, whatever this function is, I'm already telling you it's the inverse, it's going to have range 0 to infinity. So as long as you have the proper inverses, the domain of the parent function is going to be the range of the inverse and vice versa. In the next video, we will be taking a look at how to find the inverse of a function and also how to avoid the pitfalls that come with finding the inverse of a function. That is all for today's lesson. I hope you learned something new. If you did, make sure to hit the like button. If you want to see more content like this, make sure to hit the subscribe button. And if you have any questions, comments, concerns, or emotional outbursts, make sure you drop them in the comments below. Thank you.